I think, which is providing data there. So it's a single mission only, and that will not fill up all the gaps we have. So it will be difficult. But if there is a desire for doing that, maybe we have 10 minutes on tomorrow in the NWP discussion where we could think what the priorities are, and then we see.
Okay, thank you. I'm sorry, Ben. We're going to have to move on to keep to time. So our next speaker is Jan Weiss. So he's going to be talking on results from the CDAAC processing of the ROMEX data.
All right, thank you, Neil. Good afternoon. I'd like to recognize the team from UCAR that's been working on this. I'd also like to thank UMETSAT and the Joint Center for doing a lot of both technical work and coordination work, and also thank the NOAA Commercial Data Program for their support. Okay, so here's an outline of the talk. You can just see that, and I'll just go ahead here. So a lot of the missions that we process here for ROMEX, we've processed in one way or another before, either in near real time or for post-processing. So we process a number of missions in post-processing mode that we don't process in near real time mode for the science community. But we did have the privilege of getting our hands on some new missions for us through this project. So the FY3 data we'd never worked with before, any of their data, Sentinel-6, Tianmu, and Yunyao as well. So that's been useful to start gaining some experience. Of course, we're starting here from excess phases from level 1B and going to level 2. So it's not a full processing, and it's also, just to be clear, it's not a totally independent processing because we are starting from excess phases provided by UMETSAT. So again, thanks to UMETSAT for doing all of that work. Of course, the main goal of the ROMEX effort, as we've been hearing, is to do a number of interesting NWP experiments that we'll hear more about during the workshop. I'm really looking forward to that. And from everything I've seen so far, the core data set that UMETSAT is providing should be just fine for that work. I don't think there's any differences in the results that are significant enough that would matter for the NWP work. We do provide the local spectral width, which is maybe interesting for some users, so that's out there. So we didn't have to change a lot in terms of the processing that we're doing. We did change a bit on the quality control, in particular for COSMIC-2, just to make it more consistent with the other missions. So we found as we were starting this process, and I'm not going to go through these in detail, this is more for later reading, there were a couple of differences versus the operational processing for COSMIC-2 that we adjusted here. And we'll think about implementing that for operational processing as well. But the main message is just we made all the missions consistent in terms of the QC post-retrieval. You've seen a version or two of this before. This is sort of our data set on our servers. This should be very much or very close to what everyone else has. This is before QC, so I think this average number is a little bit higher than what we saw in one of the earlier talks. So, but that should explain that difference. And this is just broken down by mission. And what I'll call the big four, I'll show some plots for those, are COSMIC-2, Planet IQ, Spire, and Yunyao. So I'll do some comparisons for those. We already saw this in Weiss talk. It's just interesting. So this is just a daily movie of the geographic coverage. So 36,000 observations a day gives you very, very dense coverage every day. So that's kind of nice. And then a similar, different plot here in the local time representation. As was pointed out, there are some less dense areas in terms of local time coverage, and you can see here these polar orbits really standing out. And the bending angle statistics versus ECNWF for this is over the entire data set that we produced. And it's remarkably, I think it's really a remarkable result how similar all these missions are. There's differences and certainly in the details, but overall they're quite consistent, which is I think quite amazing actually. These are very different satellites and different providers. And then zooming in on much closer on the biases here. Again, largely very, very consistent results from 10 to 40 kilometers or so. So that is, again, really nice to see. And, actually wasn't sure what to expect, before we started this. So this is interesting. One of the things that's been starting to get looked at as a result, I think, of people paying close attention to the ROMEX data is that COSMIC-2 does sort of sit on the positive side of this, and some missions are on the negative side with similar magnitude. And it turns out we've started to look at this in the last few weeks, also together with JPL. And it seems to be that there is some correlation with profiles that are taken on the sort of off-bore site parts of the antenna pattern. And we're looking at that, and we have some theories, but we haven't quite found a smoking gun. So, I'm not ready to present anything, but we are looking at that and seeing if we can explain that or not. So some results from Rick and Jeremiah on our team. So of course they've done a lot of three-corner hat technique analyses of the many RO data sets, and including the ROMEX data set. So thanks to them for these results. On the left is a three-corner hat analysis. So you have to use at least 3 data sets. So there's some models in here, 2 models. And then the buffer is here, the observations from the missions. And then we have 3 missions here: COSMIC-2, Yunyao, and Spire. And again, largely very, very consistent observational errors computed using this technique. There are some differences with Yunyao here related to how they're doing tracking. But for most of the altitudes here, it's highly consistent, which is really nice. And then just one other example on the right, which is comparing Spire data, or focusing on Spire data using this technique, and between the excess phases processed by EUMETSAT and those processed by us. And again, just remarkably consistent. And there have been some other analyses also looking at ECMWF versus the 2 data sets. And I'm really amazed at how consistent they've turned out, actually, considering they're at least in the retrievals, completely independent systems. So taking a week of data here, so now focusing on those big 4 missions, I'll have a few metrics. So this is just geographic coverage over a week. And of course, COSMIC-2 provides lots of density in the low and mid latitudes, and the rest of them are global. And Spire with almost 18,000 per day on average, just completely fills in the map. But the others, almost do as well. And then again, just a local time representation, so we can see here, there's one orbit plane here and here as well, or pretty close. And then for this data set, Spire had a lot of polar orbiting satellites, and there is a set of low inclination ones in here that you can see here. And I don't think those are active today anymore, but they have been active at some, in the past. So, STDV is a bending angle noise metric that we often look at when we're processing data. So this is the difference between the computed bending angle and a climatology between 60 and 80 kilometers, and then taking the average of that per profile. And then I just have histograms here across the profiles, again, for a single week of data. And generally, overall pretty consistent results across these missions. Spire maybe a bit higher, but the other 3, are pretty consistent in terms of the mean and medians. And then finally, local spectral width. We've been is a metric that comes out of our system. So again, for those big 4 missions for a week's worth of data, this is the RMS of the local spectral width between 0 and 2.5 kilometers. And I think for those who have worked with this quantity, this is fairly expected in terms of the distributions. The holes are where the profiles, because of terrain, largely don't go down to that altitude range. Okay, so I'm actually doing great on time here. So we've processed the CDAAC team has spent significant effort processing the data, and it's been a great collaboration among data providers, processing centers, and NWP centers. That is, I think, bearing a lot of fruits that we're going to be hearing about at this meeting. We did use a consistent software, and we made sure our QC is consistent across the mission. So talked about that. overall, the results are quite reasonable and consistent between the missions. Yes, there are differences in the details, which I'm not spending much time on, but I will hear more about those in other talks as well. From what I've seen, comparing our results and the UMETSAT results in particular, they're remarkably consistent, which I think is a nice thing to see. It's always better than finding big differences. There is some work looking at this cosmic 2 bias. We're going to hear about that in a few other talks. Some people have more details on that, but it's too early to sort of present any results. So we're working on that together with our colleagues at JPL. I'm looking forward to seeing some of the NWP Center results. Those are coming up. And again, thanks to the partners. And I guess I'll just make one plug that the community should think about. As far as I understand, we've all signed data agreements for this data set. And I guess I'm not clear, and maybe somebody knows, but can these data now or sometime in the future, if we do some work, be made available generally to scientific researchers in universities or elsewhere? I think right now we have sort of a relatively small club of institutes that have access to the data. And you just look at this, there's so many data over a limited time frame, but I can just imagine many interesting scientific studies could be done with these data. So I'll just leave that as a comment at the end and take any questions. Thank you.
Thank you, Jan. Given your timekeeping, we have time for lots of questions, so you can grill him as much as you like.
Well,
I don't want to do
we'll
that.
keep it
I just
short.
want to answer your last question. At the ROMEX workshop, we discussed that already. Essentially, all the data will be free. Some of it already is. The ones that come from you is. The ones that comes from UMETSAT is. The Spire data actually is free because it was freed by NASA, essentially. It was now a global license. So what's remaining is Planet IQ, and they haven't positioned themselves yet, unfortunately. We have the Chinese data set. The Fengyun 3 is essentially publicly available. Yun Yao and Tian Mu both said they are willing to make the data, or they are happy with making the data available. However, they want to work with all of us on improving the relative issues they have in the data quality, and then they would like to put out a version 2 to the community.
Okay.
Not yet, but when we fix, like in Yun Yao, the slower tropospheric bias issues, that we are that we agree on that, and that they are happy with that, they will make the data free as well.
Okay, so that issue in particular, you think can be dealt with in the retrievals or the QC?
Well, as I said, I believe that the main problem is that in their lower level processing, they just cut off access or phase data way too early.
Oh, I see.
And
but
they
are
working with them. They had difficulties putting, as you have shown as well, the open loop and closed loop data together, and we are working with them. And if we sort it out, then we reprocess it again, and then they will be happy.
Okay, yeah, great. Okay, thank you.
Yes, just wanted to say, as somebody else who has an azimuthally steered phased array radio occultation antenna, we would love to be part of those discussions about correlations of bending angle bias with high azimuth.
Okay, noted. Thank you. Great. All right.
Okay. Any more questions?
Yeah. Oh, go ahead. Yeah. I hope it's not too many. Yeah.
All missions had consistent QC. Is that? I thought that wasn't a typical approach. But you did it for ROMEX, or you always do that?
Well, generally, but as we were getting started on this, we noticed that we had tuned Cosmic 2 a little bit differently than most of the other missions. And that's kind of related to the low latitude coverage and things. So for this data set, we've made it consistent, and we've not changed anything in operations, but we'll look at that. Yeah.
And the C2 bias you mentioned, do you think it's limited to ROMEX, or is it other?
No, I think it's not. I don't think it's limited to ROMEX. Okay. Yeah, it just kind of came about as part of the ROMEX analyses. Yeah, that people started noticing this. Yeah.
Thank you. By the way, great talk. So I want to say that. And then my final question is, it seemed to me that the Yun Yao spectral width was a little bit lower than the others. Is that true or not? Just looking at the colors, it's sometimes hard to tell. But...
Let's see. I think I had I maybe had a backup on that. I do not. Offhand, I don't know. So,
A little lower to me, but maybe it's just
yeah.
the color.
yeah, there's a lot of gaps. It doesn't penetrate as well. So that, I guess, I meant to point that out.
I see.
Oh, I guess I took it out. I
Okay.
had a plot of penetration. It doesn't penetrate quite
Okay.
as nicely. Yeah.
Okay.
So, yeah. All right. Thank you.
Thanks, Jan. We'll now move on. Our final speaker in this session is Ben Ho, who will be talking about the preparation of data by Noah Starr for ROMEX.
Do I do this? This? Oh, great. So I think this is the third time